This video will consist of word problems as well as practice exercises that model linear equations. And since there's two variables, we will need two equations. So that's what a system of equations represents. It's two or more equations that represent either a situation, a context, or just a practice problem. So we're going to look at through the means of graphing. So we're going to utilize the graphing calculator, and we'll do some of these by hand as well, but we'll see how we can use the calculator, use the technology to help us find our solutions. With systems of equations, our objectives is determined in the ordered pair. When you're looking for solutions to a system, you're looking for where they intersect. And if they intersect, then we would say that they are consistent equations independent of one another. If you have, so this example would mean if the two lines intersect. A consistent dependent system is where you would see the same line right on top of one another. And then your inconsistent system is where you have parallel lines. They have the same slopes, but they do not intersect. So those are the objectives for the video. Again, here's your inconsistent system, is when they're parallel, there's no solution, so the slopes would be the same. Here is your consistent system, independent of one another. They do intersect at one point, so therefore we would say they have one solution. And then what represents an infinite solution is the same line. Both lines, same slope, same intercept, same y-intercept, so it creates the same line. So let's look at an example of context. You got tickets to a movie, and they cost $7.25 for an adult and $5.50 for students. So a group of friends purchased 8 tickets for $52.75. So we're going to write a system, and what we will do is we'll be able to write systems of equations that follow the standard form. And with a graphing, we'll graph to find the solution, but we'll be able to write these in that standard form. So we want to kind of identify what our variables will be. We're going to say that X would be the adults and Y would be our students. And we do have some totals here. So this first one we would say, well, it's $7.25 for each adult, and if we added $5.50 per student, that would cost a total that we know, which is $52.75. But then we also need another equation to help us model this, and what we know is that we know the total number of tickets. So if we knew how many adults and how many children, we would add those together and we would get 8. So one way to solve this system is through the graphing technique. And in order to do that, we want to take both equations and put them into solve it for y. So we want to put it in a slope-intercept form. We want to solve it for y, and then we'll check it on the calculator. So this second one is your easiest to solve. So when we solve the x plus y equals 8, we would have y equals, subtract the x term to the other side, and I'll leave the constant of 8. So one equation will be negative x plus 8 equals y. The second equation, we're going to solve for y. So I'm going to move the $7.25 times x. I'm going to subtract it over here, so the $52.75. And then that's going to give me $5.50 y. Well, then I want to divide everything by $5.50. So my second equation would be y equals, and in parentheses, this is how I'm going to type it in, -7.25 divided by 550 times x, that's my rate, my slope, plus 5275 divided by 550. So here's the two equations. We're going to take both of those and put those in the calculator. So the first one would be -x plus 8. Hit enter, go to the second equation. And like I said, I'm going to type in parentheses the slope, so -7.25 divided by 5.5 or $5.50. I'm going to close it. I'm going to use my x variable plus my intercept, which was 5275 divided by 5.5. And I want to close it. And then I want to go to graph, and I want to see what that looks like. So the two equations do intersect somewhere around here. So this would be a consistent, independent system. And what we can do is, we know it's going to be somewhere around here. What you would do, how you would utilize the intersect method on your calculator is you would go to second, trace, because notice you're pulling up the calc. You're going to calculate something, and you're going to choose number 5, which is your intersect. So we're just moving the cursor just a little closer to that area. Doesn't have to be right on it, but just close enough to it. You can try to get it on there if you want to. And then you hit enter 3 times for this program, and it gives you your intersection, 5,3. So when we go back to our work here, the solution is an ordered pair, as I stated in the objectives. So it is 5, 3, but what does that mean? Well, 5 is your X and 3 is your Y. 5 was your adult tickets, 3 was your student tickets, and the question said how many adult tickets and how many student tickets were purchased. So you would say that there was 5 adult tickets and 3 student tickets. Example number 2. All 231 students in French class went on a field trip. Some students rode in vans, which hold 7 students each, and some students rode in buses, which hold 25 students each. So I'm going to say X. We'll say X represents vans, and Y represents buses. So my first equation is going to be 7X plus 25Y is equal to 231. There's 231 total students that are taking vans and buses. 7 is the coefficient that represents how many students rode in the vans. 25 represents how many rode in the buses. So again, I've got X plus Y because I know that there was 15 vehicles. So we're asking how many of each type. Now, certainly we can trial and error this and do a trial and error check method, and that can definitely be solved that way. But we're going to utilize our linear system method. So again, we're going to go with graphing. So this one with the coefficients of 1 is easier to solve, so we're going to subtract the x to the other side. So I get y equal -x plus 15. There's our first equation. And then we're going to do the same here. We're going to subtract the 7x term. So now it's -7x plus 231. We're going to divide by 25. And so the second equation is y equal negative 7/25 x plus 231 divided by 25. These are the two equations we're going to use as we type in our calculator. So I'm going to go into y equal and clear out what I have. And so the first equation would be negative x, go back to y equal, the negative x plus 15 is equal to, and then in parentheses, I'm going to say negative 7 divided by 25, close it, x. So there's my m, x plus, and then my intercept is 231 divided by 25, close it. And then if we hit graph, we're talking about numbers of buses and numbers of vans. So we're talking about first quadrant, real world first quadrant here, positive and positive. So we know it's somewhere around there. We could even 1, 2, 3, 4, 5, 6, 7, 8, about 8 and something. Again, second trace allows me to calculate that. So I want to choose number 5. And just trying to get my cursor as close to it as possible. You'll see it come into view here in just a moment. Into quadrant 1. So just somewhere close to it. And then I'm going to hit enter 3 times. And it should take me to the intersection of 8, 7. So remember what that means back in the context of the problem. 8, 7 is the solution. X represented 8, 8 represented vans, Y is 7, 7 represented buses. So in the context, they chose 18 vans and 7 buses. Here we're going to write the equations for Alice and how much she spent on shoes. X will say are the sneakers, and Y would be the fits. So to write that equation, first one will say she spent 131 on shoes, sneakers cost 15, fits cost 28. So we would say 15x plus 28y is equal to 131. And then she bought a total of 7 shoes. Well, I don't know how many sneakers she bought or how many fits she bought, but I know there was a total of the type of shoes that she bought there. So again, you've got your equation. So we're going to take this second one and solve it for y. So we're going to have negative x plus 7. There's one equation. And the other one, we're going to do the same as we have been. We're going to subtract the 15x, so 28y equals negative 15x plus 131 divided by 28. As you're seeing here, once we get our equation set up, solving for y is something that we have done before in class. So once we get our equation, then it's typing it in the calculator. So here's our 2 equations. And let's utilize the graphing calculator to figure out those the solution to this problem. So the first one, if we look back, we had negative 7x, y equal negative x plus 7 is one equation. And the other one was open parentheses negative 15 divided by 28, close it. There's my m, there's my x, plus, now my intercept would be 131 divided by 28. Close it. Remember, we're going to go to graph so we can see it. We're talking about pairs of shoes. So we know it's going to be in this quadrant here, quadrant 1, and we can see where they intersect. And if we go to second trace in 5, and just try to get that close as we can, hit enter 3 times, gives us the intersection of 5, 2. So if we go back to the context, what does that mean? Well, 5, 2, 5 pairs of sneakers, 7 pairs of fits for Alice and how much she spent. Example 4, I've got 2 small pitchers and 1 large pitcher. So we're going to say that X is our small pitcher and Y is our large. It wouldn't matter if we flipped these and said X was large and Y is small. It's not going to matter. It does matter when you set up your equation, but if in this case we're just choosing X for small and Y for large. So we know that 2 small pitchers plus 1 large pitcher can hold 8 cups of water. However, 1 large pitcher minus 1 small pitcher holds 2 cups. So I know that it's not quite like we've been working, because the x's have been kind of coming first in that ax plus by equals c format. But that's not a problem because we're using the application of graphing, the tool of graphing, so we're just going to solve them both for y. So this top equation, I'm going to subtract the 2x term, so I get negative 2x plus 8. So there's one equation. And then here I'm just going to add the x over. So I get x plus 2. So there's my 2 equations. Negative 2x plus 8 and x plus 2. So let's go to the calculator. Clear those out and type in negative 2x plus 8. Enter. And x plus 2. We're going to graph those. One's positive sloping, one's negative sloping. They're not, they kind of look perpendicular, but they're not quite perpendicular. They do intersect. And second trace, go to 5, hit enter, and then as close as you can, which looks like it's going to be at 2, 1, 2, 3, 4, 2, 4. So what does that mean? Well, that ordered pair means something in our work. And 2, 4 just means that there was 2 small pitchers and 4 or 2 cups and 4 cups for your large and for your small. So you can always check these. I haven't done that in these equations, but we can always check if 2 represents the small cups. 2 times 2 is 4 plus 4. 4 plus 4 gives us 8. And then if we took 4 and subtracted 2, we would get 2. So it's asking how many cups of water can each pitcher hold. Well, the small pitcher can hold 2 cups and the large pitcher can hold 4 cups. This next one, test has 20 questions worth 100 points. So a test has 20 questions, and we know that there's a total of 100 points. The test consists of true, false, and multiple choice. So I'm going to call X the true, false, and Y the multiple choice. Now we know that the test consists of true, false questions worth 3 points each. So true, false, each true, false question is worth 3. Each multiple choice is worth 11. We know that should give us a total of 100 points. Now this 20 questions is necessary because however many true false plus however many multiple choice gives us 20. So we're going to take our system and solve it for y. So this top equation will be 11y, subtract the 3x, so negative 3x plus 100, divide by 11. So we'll get y equal negative 3/11 in parentheses x plus 100 divided by 11. And there is equation number 1. And then equation number 2 is simple, subtract the x, negative x plus 20. So here's the 2 equations that we'll type in the calculator. And we're talking true, false, we're talking multiple choice. These are all should end up in quadrant 1. So first equation in parentheses, negative 3 divided by 11, close it, x, so there's my m, x plus b is 100 divided by 11, close it, enter, and the other one was negative x plus 20. Graph it. We should see it hit in quadrant 1. Well, it should hit in quadrant 1, but why can't we see it? Well, if we go back and look, we have an intercept of 20, which this is only a 10 by 10. So what we're going to do is we're going to zoom out 1 click. So I went to zoom, 3, hit enter, and we see that it's over here. So second trace allows us to calculate again. So 5, and then I'm just going to get that close as we can. Hit enter 3 times, and then we get 15.5 as our solution. So go back to our context and look at what that means. 15, 5. Well, 15 was true, false. 5 was multiple choice, so you had 15 true, false questions and 5 multiple choice. And 15 plus 5 is 20. And if we substitute 15 times 3, 5 times 11, so you get 55 and 45, which gives you 100. So there's your solution. We're going to skip example 6 there and go into 7. Notice this is one system. These are just 2 different problems. So if we look at, they're both already in slope-intercept form. So we could plot this, and we could plot this, at negative 9, and then apply our slope of 4 to 1. 1, 2, 3, 4 to 1. 1, 2, 3, 4 to 1. 1, 2, 3, 4 to 1. And we can draw our line if we were doing this by hand. Here I'm at negative 3. Plot my intercept, and then I'm at 1, up 1, over 1. Increase 1, increase 1. So we see where they're going to intersect. It's going to be right here. Calculator will graph it much better than I can do that by hand. But that means that it would be 2, negative 1 as our solution. Now if we look at the second one, it's still in that standard form, so we're going to solve the top one for y, so y equals negative 4x plus 2, and we're going to solve the second one for y, and since this is minus y, I'm just going to go ahead and move the y and make it y equal x plus 3. So that's just allowing me to, the y's on the right side, but that's not a, well, what I do, and I'm going to have to move the y over here. I'm going to have to subtract the 3. So I'll do that again. If I add the y to the right side, I'm going to have to subtract the 3, so that'll give me x minus 3. So here are the two equations that we can type into the calculator. And I'm going to go back to Zoom 6. Gives me a standard window. Go to y equal and clear out what's there. And I'm going to type in negative 4x plus 2 and x minus 3. And I'll go to graph. And this is intersecting in quadrant 4 at 1, negative 2. Now there's no context to this, so all we know is that 1, negative 2 is the solution. Example 8, part A. Notice everything's set equal to 0. So I'm going to leave, actually I'm going to add just the 2y over. So I'm going to leave the x plus 8. I'm going to move the 2y. It's minus 2y, so now it's positive 2y. And divide everything by 2. So I get 1/2 x plus 4 is equal to y. There's the top equation, this one right here. And then I'm going to do the same. I'm going to add the 2y over, so I get negative 6. And then I'm going to have to add the x over here. So negative 6 plus x equals 2y. I'm going to divide by 2. And I'm going to get negative 3 plus 1/2 x equals y. Now what's nice about this is if you look, the slopes, positive 1/2, positive 1/2. Since the slopes are the same, we should see parallel lines, which would give this an inconsistent system. So let's look at graphing it. So first equation we'll say is 1 divided by 2 x. So there's my mx, and then minus 3, so my intercept is a negative 3. And then the other equation has the same slope. If we go to graph it, there's no need to find an intersection or going to second trace because there is no, there will never be an intersection here because of the parallel lines. So this would be a no solution. Since we have parallel lines, this would be a no solution. And then if we look at part B, and I'm going to add the 5x. So now I got 5x plus 2 and divide by negative 2. I'm going to have y equals negative 5/2 x minus 1. So there's the top equation on part B. It's this one right here. And then here I'm going to add the 4. Leave the 2y. Add the 4, so I get negative 5x plus 4 and divide by 2. And I get negative 5/2 x plus 2 is equal to y. And when I get to this point again, notice the slopes. Negative 5/2, negative 5/2. Slopes are the same. We're going to have parallel lines. This is an inconsistent system, and it's a no solution. Number 9, part A, I'm going to solve for y, so 2y. I'm going to subtract the x and add the 4. So I'm going to subtract x to the other side and add 4. And then I'm going to divide by 2. And so y equals negative 1/2 x plus 2. And then I'm going to, since y is on the right side, I'm just going to subtract the 3. So I'm going to get negative 6 minus 3 equals 3y. Divide by 3. And I'm going to get negative 2x minus 3/2 equals y. Oops. And I noticed just with my work here, I got sloppy. So I'm going to start over because there's a mistake because I got sloppy. I'm going to start over with this for part A, 2y. I'm going to subtract the x and add the 4 and then divide by 2. So that's y equal negative 1/2 x plus 2. And then the second one here is I'm just going to go ahead and divide by 2. I think I started with one equation and jumped to the next one. 2y is equal to negative x plus 4, so I'm going to divide by 2 here, here, and here. So that gives me negative 1/2 x plus 2. So if you look at the two equations, what do you notice? Well, the slopes are the same, but the intercepts are the same. So what you have is a consistent dependent system, which is the same line. So we know that we'll go through the y-intercept of 2. So if you plot this one, it'll be decrease 1, increase 2, decrease 1, increase 2. So this will be this first equation. But if I go to graph the second one, it would be just right on top of one another. So this is your example of it's the same equation, so it would be an inconsistent dependent system, which would represent this here. So we did see examples of no solution. So that means they have the same slope, different intercepts. We did see a consistent independent, which was most of our context problems, had an intersection of some point, and then the last one that we looked at had a consistent dependent system, which was the same line. And so that discussed the objectives and the ordered pair representing a solution to a system.